In this video, I'm going to show you how to calculate standard deviation. What standard deviation is, it's a measure of how spread out the data is around the mean. So a lower standard deviation means the data is very close to the mean and that the numbers are more consistent because they're very close to being the same. A higher standard deviation means the data is scattered farther away from the mean. So there's less consistency. So in this example, we're going to look at two individuals, Brendan and Jordan, who are picking bushels of apples for a local farmer. The farmer records how many bushels each person fills each hour. So here's a table that represents the number of hours and the number of bushels both Brendan and Jordan pick in that time each hour. So which person picks more bushels of apples per hour? So for this, we go back to what we learned in a previous lesson with like mean, median, mode. We'll look at the actual mean for each of them, so the average that each of them picks. So if we start with Brendan, we're going to look at the average hours or the average number of bushels he picks. So if you remember, this is represented with X with a bar over the top. And what we're going to do is add each of these numbers, 5 plus 6 plus 6 plus 5 plus 7 plus 6 plus 5, which will add up to 40. And we're going to divide that by the number of hours. So there's a total of 7 hours, or 7 numbers. Now if we divide this and round this to, we'll say the hundredths, so 2 decimal places, this will be 5.71. So he picks about an average of 5.71 bushels per hour. On the other hand, if we look at Jordan, Jordan's average is going to be this. If we add his up, we'll get 41. And if we divide this by 7, we get that Jordan's average is actually higher. It's 5.86. So in terms of which person picks more bushels per hour, it would be Jordan because his average is higher. So we'll put Jordan picks on average more bushels per hour. And it's not that big a difference, but it is a little bit more. Now, another way to look at this, because again, we could just go based on Jordan's average and say, okay, overall he's picking more an hour. But if we look at B addresses who is more consistent. For consistency, we look at the standard deviation. Again, a more consistent picker is going to have a lower standard deviation. This means that the numbers are very close together, whereas someone whose numbers are more spread out will have a higher standard deviation. Now, if you quickly look at these, it looks like Brendan's numbers are all very close. Like a lot of them are 5 and 6. There's 1, 7. So it looks like he's very consistent, whereas Jordan is a little less consistent. Sometimes he's got 8, sometimes there's 4. So after that 8 bushels, he must have been tired and went down to 4. Okay, it's a little less consistent, which may show or should show when we calculate the standard deviation. So this is what we're going to do. We're going to use this table, which I've created already. And in this first column under his hours, Brendan's hours, we're just going to write these hours here. So 5, 6, 6, 5, 7, 6, 5. Now the actual formula for calculating the standard deviation is down here, okay, which we could just use the formula, but it will be easier to use this table to get us to this point where we can put these numbers in. In the formula, we're trying to find the sum of the deviations from the mean. So what we're doing first in this part of the table is we're finding this top part. We're finding each individual number, how far it is from the mean or the average, and then we're going to square it. So in this first one, I'll write this out. Really what we're going to do is we're going to take 5 and we're going to subtract Brendan's average, which is 5.71, and square this. And when you do, you should get 0.5041. And then what we're going to do for the next one, we're going to do the same thing. We're going to take 6 and we're going to subtract the average and square it. So we're going to take each individual number of Brendan's data and we're going to subtract the mean. And this tells us how far each number is away from the mean. And then we're going to square it so that they're all positive numbers. Because if they weren't positive and we added them, then we should get 0. Because they should be an equal distance above and below the mean if the mean is the average. So look, since 6 is the same, we know that this number is also going to be 0.841. 5, we've already calculated 0.5041. So all of these 5s are going to be the same distance from the mean, and all the 6s are also going to be. And then the 7, we're going to do 7 subtract 5.71 and square this, and we should get 1.6641. Now what we're going to do is we're going to find the sum of these totals. All right, and this will give us what will be in the numerator of this fraction that's going to be square rooted. So what we're going to do is we're going to add each of these numbers of the squared terms. And if you add those, you should get 3.4287. Now lastly, to calculate the standard deviation, what we're going to do is we're going to find the square root of 3.4287, and we're going to divide this by the number of numbers. In this case, there's 7 numbers total. So if we divide this, and I'll write this below the chart since I'm running out of space here, but if we take the sum of the terms, divide them by 7 and square root it, we should get that his standard deviation is 0.70. And what this is just saying is it's basing on average how far each group of data is about from the mean. So from 5.71, it does increase almost 1 above and 1 below. If you look at most of his data, it's right in between there. So again, this low standard deviation indicates that the numbers are very close together. If the standard deviation was 0, that would mean all the numbers are the exact same number in the data set. So in this case, it's not 0, but it's very close to 0, so that means it's quite consistent. Now, if we look at Jordan and do the same thing, we're going to write his numbers out here. So 6, 7, 8, 4, 5, 5, 6. I'm going to remind you, I got these from the table. These are the number of bushels he picked each individual hour. And what we're going to do is subtract each of these from his average picking hour, the average number of bushels he picks an hour. So 6 subtract 5.86 and then square this. If we do that, we should get 0.0196. Again, any other number that's 6 in his data set will have that same value for the standard deviation. For 7, we're going to subtract, again, the 5.86 and square this. And then this would give us 1.2996. Now to save some time, I'm going to just write the rest of these in. If we did it with 8, 8 minus 5.86, we would get 4.5796 after we square it. For 4, we would have 3.4596. For 5, we would have 0.7396. Now again, I want to remind you, you will need to take each of these numbers and subtract the mean and then square them to get these numbers. Then if you total the values that are in this column, we would get 10.8572. Now the reason this number is bigger is because the data, these numbers are actually a little more spread out from the mean than Brendan's were. So in terms of calculating the standard deviation, again, what we would do is we're going to take the sum of these numbers, which is 10.8572, and we're going to divide them by the number of numbers, which there are 7 total numbers, and square root it. Now if you do this, we're going to get 1.245. So this gives us a different option for comparing Brendan and Jordan. Okay, in terms of the average, Jordan picks more per hour on average. But in terms of consistency, if you look, Brendan is more consistent. His standard deviation is lower, which makes him a more consistent picker. So in terms of this, somebody may choose to pick Brendan over Jordan because he's consistent in the amount of bushels he picks every hour, so he can depend on him more.